So what we're talking about today is multiplying and dividing fractions. And the first thing I did was I gave you guys examples with numbers here. So if I was to multiply 3/5 times 7/8, the first thing you'll notice is you just multiply the numerators and denominators respectively. So I do 3 times 7 and 5 times 8. That's the first step. And I end up with my result of 21/40 here. Important to note that I would want to simplify the fraction if possible, but this fraction is actually already in simplest form. There's not a common factor in 21 and 40. That's what multiplication of numbers looks like. The nice thing is division is not much different. The big thing with division is you multiply by the reciprocal. So it says the reciprocal of 3/4 is 4/3. All right. And it's just because you multiply them together, the reciprocals multiply to equal 1. So in this example, what we're going to do is we're going to multiply 5/7 by 4/3 instead of dividing by 3/4. So instead of dividing two fractions, multiply by the reciprocal. It makes it a lot easier. And in this one, we can say, okay, instead of 5/7 divided by 3/4, we'll do 5/7 times 4/3. And then you just do 5 times 4, 20, 7 times 3, 21. And it's already in simplest form. So that's the idea for multiplying these numbers here. All right, so there are 12 problems here. I want you guys to practice. So writing them as a single fraction with multiplying the numerators and multiplying the denominators, and then simplifying as needed. I know number 1, for example, definitely needs to be simplified when you get your answer. So take a couple minutes to work on those 12 problems. For problem number 5 here, we have 3 times 1. That's 3 over 8 times 8 is 64. So that's what we'd leave that one at. Problem 6, we're going to get 56 over 50, which means we could, I think, take a 2 out of both of them, and we'll end up with 28/25, and we can't really simplify that anymore. Problem 7, you end up with 24 over 20, and you could say, take a 2 out of each, you're going to get 12/10. Take another 2, you're going to get 6/5. All right, problem 8, 15 times 3 is 45. Oops, this one didn't need to be flipped. I flipped it, I didn't need to. So let's go ahead and, let's go ahead and fix that. It should just be 15 times 2 and 4 times 3. So that's going to be 30 over 12. Divide both of them by 3, you're going to get 10/4. Right. Is that right? Yeah, and then we can divide both of them by 2. So we can divide both by 6, I guess, initially. Very good. 6/5. No. Divide by 5, and you're going to get 6. Or divide by 6, you're going to get 5. That's what it is, 5/2. Sorry about that. Okay, so 5 over 2 for that one. Okay, so for problem 9 through 12, we start seeing variables in here. So number 9 is just going to be 2 times x over 4 times 3, just 2x over 12. And then we just have to get rid of those like terms. 2 over 12 is going to be 1/6. So it's going to be 1x over 6, or just x over 6. That's what we do for something like that. For problem number 10, I have 3a squared, and what we talked about yesterday was you just do 3 times a times a, and then times 4 times b times b times b. And that'll be the numerator. The denominator is going to be 2 times b times 9 times a. And what we can see here is, hey, I've got an a in the numerator, an a in the denominator that can go away, a b and a b that can go away. And I'm going to have 3 times 4 is 12. And then I'm going to have 1a left and 2 b's left in the numerator. And the denominator is 18, 9 times 2. And then 12/18 actually simplifies as well. That becomes 2/3. So this simplified expression is going to be 2ab squared over 3. All right, that's how we kind of break those ones down once we have the variables in there. All right, just combine them all. And then we go ahead and figure out the simplification afterwards. the last one, or not the last one, but second to last one, we're going to get n over 6 times 3 over 1. So we're going to get 3n over 6. 3n over 6 becomes 1/2, so this simplifies to 1n over 2. And that's how we can write it. All right, now we're on our last one. I have an x plus 1 quantity squared, so I should be able to write that out as x plus 1 times x plus 1 over 10. The second part would be 4 over x plus 1. And now if I combine it all, I'm going to get x plus 1 times x plus 1 times 4 over 10 times x plus 1. And I have an x plus 1 that's both the numerator and denominator. Those go away. I've got a 4/10, which can simplify to 2/5. And that leaves me with 2 times x plus 1 over 5. And then the very last step, I need to just distribute that 2. So I'm going to get 2x plus 2 over 5. And that's what number 12 is going to look like for me. So don't forget about that last step to simplify, condense, get rid of those parentheses, whatever you need to remind yourself to do for that. Okay. So when we're talking about rational functions here, or multiplying rational expressions, the rule for multiplying rational expressions is the same rule for multiplying numerical fractions. All right, just like what we saw in problems 1 through 8, we follow the exact same rules in 9 through 12. All right, we're going to multiply the numerator. We're going to multiply the denominator. And then we're going to write the new fraction in simplified form. We're going to follow the same two-step simplification process as we did when we divided, as we do when we're dividing rational expressions too. All right, so we'll take a look at that example as well. All right, but first, example 2, multiply the rational expressions and simplify by dividing the factors. So what I would recommend for these types of problems, if you're not sure, like when in doubt, expand it out. So for example, we have 8x to the third, so I'm just going to write it out as 3x's. And then we have 7 and 4 more x's and 3 y's. So what you could do is you write it all out. How many x's total do we have? 7. So technically, this whole thing would multiply to 56, x to the 7th, and then there's 4 y's, y to the 4th. So notice that we had x to the 3rd and x to the 4th. It's not 3 times 4. It doesn't become x to the 12th. It becomes x to the 7th. We're actually adding all of the x's together. How many x's are there? There are 7 of them. Okay, so that can be a little tricky. We did a worksheet like this a while ago where we talked about properties of exponents. We did that way back in mod 2 before we talked about logarithms. All right, but that is that's the idea for these types of problems. For the denominator, I could write it as 2x, and then there's 2 y's, and then a 4y. So technically, I could say this is 2xy to the 3rd. Now, I could write it out like that, but I think it's going to be a little easier for me personally, rather than doing all that multiplication, is to say, hey, look, there's an x in the numerator, x in the denominator, and get rid of those. Then get rid of a y and a y, and then get rid of another y, and a y, and a y. And then technically, this denominator, oops, it should have been 8xy cubed. Technically, there's an 8 in the denominator and an 8 in the numerator, so all of those would go away and just become a 1. So what I'm left with 2 x's, 3, 4, 5, 6 x's. I'm left with 1 y, and I'm left with a 7. So after all of that, I'd be left with 7x to the 6th y. I think what gets really difficult with these types of problems is the more x's we get, the more y's we get. You write out a lot of them by hand, and it's kind of hard to track this way. So looking at the other one I have, 56 x to the 7th over y to the fourth over 8x y to the third, I can say, hey, 56 divided by 8, that's 7. And then x to the 7th divided by x, I'd just be crossing one x out of both, so I'd have 6 left there and get rid of that one. And then y to the 4th over y to the 3rd, I'd have, could be getting rid of 3 y's on the bottom, 3 y's on the top, I'd left with 1 y on the top. So 7x to the 6th y. I get the same answer both ways. So it's really up to you guys how you want to simplify these expressions when you get down to it. All right, but just make sure that you're very diligent and you're paying attention to all of your factors and everything. It's easy to make mistakes on these types of problems. All right, example B, 3x minus 3x squared times x squared plus x minus 20. Instead of multiplying all of these parts out, I would recommend just like, let's try and find a factor. So for example, this first part becomes 3x times 1 minus x. And then the other side, I have a, let's see, the denominator there is x squared plus 4x minus 5. We'll go ahead and break down that denominator. With the minus 5, one of them's going to be negative, one's going to be positive. I think it's going to be a plus 5 here. Give me a positive 5x and a minus 1x. There we go. So the denominator is going to be x minus 1 and x plus 5. And when I break that down, that means, because I just broke this part down, I want to look at the numerator on the other side, and I want to say, hey, that numerator, hopefully it has an x plus 5 or an x minus 1 in it. So that way I can simplify easily. So I'm going to start with the x plus 5 because I see a 20 there, so it makes me think that x plus 5 is a real possibility. And because it's a minus 20, I would have to do a negative 4 over here. I get a negative 4x, a positive 5x, and sure enough, I get a positive x in the middle. Perfect. This is great because that means I'm going to be able to divide out an x plus 5. And the denominator is still 3x. So that's the first part. Let's get it factored as much as possible. Now I can rewrite it as a single expression. 3x times 1 minus x times x plus 5 times x minus 4 all over 3x times x minus 1 times x plus 5. X plus 5s go away, and I have a 3x and a 3x that'll go away. That's kind of nice. Now, one thing that kind of irks me on this one is this 1 minus x, because it looks so close to x minus 1. And what we can do with that 1 minus x is we could technically rewrite it. I'm going to rewrite it as negative x plus 1. All right, which doesn't look as close to x minus 1 as it did before. But what I can do is I can actually factor out a negative 1 and rewrite this as x minus 1. So what that does is it lets me rewrite the numerator as negative x minus 1, x minus 4 over x minus 1. And now I have an x minus 1 and an x minus 1 that I can divide out. Just because all I did was I factored out a negative 1. And I was able to rewrite that one part of the expression and simplify this just a little bit more, which makes it a little nicer for me. So I'm left with negative x minus 4, negative times x minus 4, and the denominator is just a 1. The last step would be just to distribute that. And I'm going to get a negative x plus 4. So my answer would be negative x plus 4, or I could technically write it as 4 minus x as well. I would accept either one of those answers at the very end. But that's the most simplified this problem is going to get. Because that 1 minus x looks very similar to x minus 1, you got to ask yourself, is it possible to like take out a negative 1 and change it just a little bit? And it turns out it is possible. All right, I'm going kind of fast here. I'll give you guys a second to finish this part down if you need to. And then we'll take a look at part C here. All right, looking at the last problem here, part C. X plus 5 over x squared minus 1. And then the second part was x squared plus 2x plus 1. Think about that as like over 1. And that might help you realize how we want to write this. x squared minus 1, that's a difference of squares problem. So I'm going to write that as x plus square root 1, x minus square root 1. And then the next part, what would technically happen is x plus square root 1, x minus square root 1. The square root of 1 is just 1, so that works out nicely for us. X squared plus 2x plus 1. I'm hoping there's an x plus 1 or an x minus 1 in there. Because I see plus and plus, I'm guessing there's going to be at least one x plus 1 in there. And it turns out the only factors of 1 are 1. So it's going to become x plus 1 times x plus 1 there, which is kind of nice for us, all over 1. That's what this one would look like. And then the numerator is going to be x plus 5 times x plus 1 times x plus 1. Denominator is going to be x plus 1 times x minus 1, because we had a times 1 there. We're going to get rid of an x plus 1 on both numerator and denominator. So what we end up being left with here is x plus 5 times x plus 1 over x minus 1. And then the last step is to multiply out the numerator, put it back into standard form. And we end up getting an x squared there, a plus 5x there, a plus 1x there, and a plus 5 there. That gives us a positive 6x in the middle. X squared plus 6x plus 5 over x minus 1, and that's the most simplified this is going to get right here. All right, that's the answer for part C. All right, so steps for multiplying rational expressions. All right, same thing as what we talked about last time. We're going to start each problem by multiplying the numerator and denominator, respectively. Actually, you know what? I'm actually not going to start by doing that. I'm going to start by saying I'm going to simplify numerators and denominators, right? Because that's what we really did. Numerators and denominators. Or I should say factor numerators and denominators. That's probably a better word. Sorry, I'm missing my vocabulary today. Factor numerators and denominators. That's what we wanted to do first. I apologize for the horrible vocabulary usage there. And then my next step is to go ahead and combine things. So multiply numerators and denominators. And then finish up by dividing like terms. Okay. So I finished by dividing like terms. That's it. Okay. That's what the 3 steps are for multiplying rational expressions. Okay. When we're dividing rational expressions, that's the only other thing we're doing. Exact same steps as multiplying, except we have to do the first step of flipping the second fraction and multiplying by the reciprocal. So divide one rational expression by another. We're going to multiply the first rational expression by the reciprocal of the second rational expression. Okay, so the only difference, like I said, the first step, 7x over 2x minus 10 times x squared minus 11x plus 30 over x squared minus 6. Before I do anything else, the very first thing I want to do is flip it. And the reason I say that is because you could start factoring your numerators and denominators, but you might forget to flip the fraction. I see that mistake a lot on tests where students just get excited about the factoring part, and then they accidentally do a multiplication problem instead of a division problem. So I flip it first, And now I can go ahead and start factoring things. Like the denominator here is 2x minus 10. I can pull a 2 out of there and I can get an x minus 5. Now I'm hoping that there's an x minus 5 hiding out in this equation right here, so that I can get something simplified. So I'll go and do a box method. X squared minus 11x plus 30. Check out to see if there's an x minus 5 there. If this is a negative 5, then that means this has to be an x minus 6. That gives me negative 6x, negative 5x. And sure enough, it adds up to negative 11x in the middle, so that's perfect. So I double checked it to make sure it works, and it does. So I get x minus 5 and x minus 6. The last part, x squared minus 6, that's a difference of squares. So I'm going to get x plus square root of 6, x minus square root of 6 there. And unfortunately, square root of 6 is not going to simplify for me. So I just have to leave it as x plus square root of 6, x minus square root of 6. And then in the numerator, I get 7x times x minus 5 times x minus 6. And then I can get rid of those x minus 5s in the numerator and denominator. And then 7 divided by 2 doesn't work. I can't do x minus 6 divided by x minus square root of 6. That's not the same thing. So the last part would be to multiply things together. I'll just rewrite this real quick and say 2 times, this one would kind of go back to x squared minus 6. Couldn't really do anything to simplify that. The last step, I'd multiply my 7x. I'm going to get 7x squared minus 42x over 2x squared minus 12. And that's what this one ends up being. It doesn't look great, not very well simplified, but that's the best I can do. All right, for this problem, unfortunately, when it's all combined. Okay, just don't fall for the trap of seeing an x squared minus 6 and an x minus 6 and thinking you can simplify that somehow. It won't work, unfortunately. So we're stuck with this kind of ugly big thing still. So steps for process for dividing rational expressions. Step 1, I start each problem by multiplying the first expression by the reciprocal of the second. Reciprocal of the second. All right. Then, after that, I follow the same steps as multiplication. And that's it. All right, that's the trick with division. So not much more complicated than the multiplication aspect of it.